Hello, everyone. We are super excited to be here and chat about OpenMetrics and its potential future. Let's dive in. We all know the core aspect of Prometheus ecosystem depends on the fact it scrapes metrics. For that, it requires some sort of transport, which we call the exposition. In this context, the exposition format is essentially an HTTP response content, the scraper, for example, Prometheus, can use to periodically collect the current metric values from the exposer. So, for example, your application. For instance, you are probably familiar with the text exposition format, which is what you typically see when you just hit this slash metric endpoint. And it became a Prometheus signature at this point, right? And it's really one of the main reasons why Prometheus is so widely adopted. You probably heard also about OpenMetrics 1.0 that came in 2020, standardizing Prometheus text format and added a bunch of stuff on the way. Well, around a year ago, Prometheus project started a new working group to deliver OpenMetrics 2.0. And since then, we formed a solid goals and ideas on what 2.0 should solve. And we are here today with Cryo to share it all with you. So make sure you fasten your seatbelt because there are some ideas that are very ambitious, but we think they really represent what Prometheus is slowly evolving into. And it's still open page, so don't worry if you don't agree with things, if you don't like things. So please, we are making this talk exactly to hear your feedback. So let us know after the talk, what do you think, what would you improve, or maybe you like it. So at the end of this talk, I want you to know what exposition formats we have in the ecosystem and how to navigate them. Which one? I don't know. What should you choose? I want you to know what OpenMetrics 2.0 changes are, what we are thinking about, and how you can join and help our effort. But let's start with a short introduction. I'm here with Cryo.
Yeah, my name is György Krajcsovits, Cryo for short. I work at Grafana and I'm a maintainer in Prometheus, Grafana Mimir, and a co-owner in OpenTelemetry, and I specialize in native histograms.
And my name is Bartłomiej Płotka. I work at Google. I'm responsible for Google Managed Prometheus and service, and I maintain lots of stuff, usually in Go, in open source. I'm also mentoring. I wrote a book called Efficient Go. And I also, last year in my free time, I started motorcycling. But this year, I had extra fun sharing this passion with two new humans. I try my best to include them, right? Okay, so let's talk about exposition formats. What do you need to know about them? Well, first thing is that there are different flavors of you can use in Prometheus to collect your metrics, notably multiple versions of text and a protobuf. For example, this is a snippet of Prometheus configuration, kind of recently added, that allows you to configure the preferences of scrape format from the scraper perspective, globally or per scrape job. Prometheus will use this configuration for content negotiation. So during HTTP request to scrape a metric endpoint, the scraper tells what it accepts and in which order, and the exposer essentially chooses the first it supports. So for example, in this example, if we reach an application and it doesn't support protobuf, it should, and supports OpenMetrics, it should kind of respond with OpenMetrics. So just by looking on this config, there are some decisions to make, right? As a user, when I configure Prometheus, like what format should I prefer? And also as an application exporter developer, what to implement, what I should focus to have in my application to really speak the same language as Prometheus and other scrapers. Does it matter? What are the differences? Let's try to answer those questions. So it all starts with Prometheus project being open source in 2012. And so the first question to you, to the audience, what do you think was the first exposition format? What are your guesses? Tell me. No, Julius, not Julius. Anybody else? What was the exposition format? Was it text? Was it protobuf? Okay, you're saying text, protobuf. It was JSON, not XML. It was actually JSON, turns out, right? So in May 2013, there was, JSON was introduced together with Prometheus project, and I recently spoke with Matt Proud, the kind of like the author of the initial Prometheus bits, and apparently JSON was really the fastest solution to get things started, to get an MVP, to have something working, right? It was, it offered that okay functionality represent, initial Prometheus primitives like gauges, counters, and histograms. So it was up to date to what Prometheus was offering in the beginning. But the next important benefit that was noticed for JSON was that it was sort of human readable, right? It was, which is a critical really aspect for individuals debugging your application without the need of any tooling, any scraping. So, and as you already see, this aspect of human readability is a really core important use case we deeply care until this point. However, readability of JSON wasn't perfect, right? There was cognitive load and there are some nuances in the format. But really the biggest challenge comes from efficiency aspect, right? So JSON decoding was obviously slow. The format didn't support streaming and encoding and decoding. And essentially it meant like higher latency and higher resource usage, higher cost. So that's why a month later, protobuf format was introduced, June 2013, not text. First version, was released in June, and it was absolutely not human readable at all, right? But it was fast. Prometheus protobuf generally was, fast to parse and result in a smaller payloads. But really, what's more important was that it was capable of streaming factor, right? So you could stream things on the way, just make things faster and cheaper. And this is mainly not due to protobuf, but actually how this special delimited encoding that we kind of like innovated with. However, probably the main selling point actually about protobuf is the backward and forward compatibility of this proto format. And we really learned about this benefit, or like really use this benefit like just recently, or like last few years. But it really proven to quickly enable Prometheus to innovate, quickly test on things, and really adopt the format to the latest Prometheus features. And as a result, later on, we were kind of adding more stuff to the protobuf. And when exemplars were implemented in Prometheus, we could immediately adopt it on the exposition formats with protobuf and immediately add it without breaking changes. Then the moment native histograms appear, protobuf was supporting them straight away. And SDKs could adopt. We could kind of like test things out. So it's actually very, very important factor that makes protobuf really compelling. But finally, at some point a year later, the initial Prometheus text format was introduced, and it was kind of replacing and deprecating the JSON format. And yes, it wasn't flexible, and as protobuf, it was way more readable. But it wasn't just objectively readable, actually. It introduced this amazing rule, this aspect, which we really try to aim again nowadays, is that what you see is what you query. This rule is super important. It means that you can literally copy the metric name and all these labels, put in your monitoring system, in your PromQL, and it will just work, right? And it kind of vice versa, right? It connects metrics from others dashboards, especially if you have them configured somewhere. You can take them and find metric source very easily. You can grep for this metric in its format. So this rule is really amazing, and we would love to keep this rule going, kind of. And it wasn't just that, the text format was actually very writable, right? So even by hand, you can easily write those metrics up. And you might ask, like, why this matters? Like, who type metrics and expose them by hand? Turns out this happens, but more than that, it means coding and adding support for like representing those metrics programmatically is just now super, super trivial. You can use bash script for that. You can do anything. And it unlocks range on environments where you don't have access to JSON library, protobuf library, or not mentioning SDKs, right? So it was super, super, important. And what about efficiency? Turns out text format is actually pretty fast, right? And it was especially efficient and reliable because of a stateless aspect. So what I mean by stateless is that when you are parsing, you know the full context of the metric just by looking on one line. You don't need to store anything on top. You don't need to store anything later. Everything you need is in one line, right? And it makes things super, super cheap, super, super reliable. And you might say, okay, help and type is not in one line. But you need to think that in 2014, we didn't use this information. It was just human readable hints, right? So it wasn't integral part of the format. As you can imagine now, it's changing. So, we have to improve things. But eventually, in November 2020, Prometheus text was formalized by this independent CNCF project called OpenMetrics, which was outside of Prometheus, actually, with Prometheus members. But it also included various different ecosystems like M3DB, OpenCensus, and vendors contributing to this format. And it was before OpenTelemetry existed. But eventually, a year ago, OpenMetrics was merged officially to Prometheus project. So now we kind of own it. And it really enabled us to really start thinking how we can improve things, maybe make things cleaner and up to date with the latest Prometheus features. OpenMetrics was great. It standardized Prometheus text format, added small features, and generally inherited the same pros and cons of text format. And it was, both text formats, from Prometheus, OpenMetrics, doesn't matter, they were super, super successful. But 5 years has passed, right? So Prometheus evolved, and it's time for another iteration. So let's walk through the few things, sort of 3 high-level things we want to address. First is the stateless aspect, right, that I mentioned. For example, we can kind of see the effect of it with this new created timestamp feature, which allows, which allows representing cumulative counter start time more accurate and making counters more accurate generally. And actually it enables delta type in Prometheus in some future. The created timestamp is currently exposed in OpenMetrics as a separate metric, as a separate series with this created suffix, like a special metric that holds the timestamp value for a related metric. Okay, but what metric exactly? What metric is, this create timestamp is for? Turns out when you are parsing, it's not so simple because there might be line above, it might be line below, but it's generally with the same metric family, but different suffixes, all the same labels, but except LE label, but sometimes only for histograms, actually also except quantile label, but only for some. You see the point, like it's kind of getting complex, and it's not the complexity of parsing, but actually the reliability of it that makes things really tricky to use in practice. And we've proven that because the moment we tried to use it like a few years ago, during some mentorship, it wasn't easy, right? Like, and combined with all of those edge cases when somebody has an invalid spec, and kind of detecting this, it was effectively impossible to use reliably. And lack of reliability means more cost, less efficiency for parsing. You pay more for your monitoring. Now, really the same problem occurs with other stuff, like for classic histograms and summaries, for our complex types in Prometheus. If you try to parse those individual series as one thing, right, and as a single series, like native histograms, like maybe native summaries one day, it's really prone to the same reliability errors because you have to combine those things as a one thing. You have to find relation between those things. And on top of that, once you combine them into one series and you start querying it like one series, it actually breaks the rule of what you see is what you query. Because, imagine right now, native histograms, they don't have bucket suffixes, right? And again, this is really similar with type and unit. Now, those problems I mentioned, those are like would and what if, and it feels like speculations, and those problems didn't exist 5 years ago. That's why it was chosen like that. But today, those are not speculations. We're actively evolving Prometheus, and there are certain features you enable that the moment you enable them, you hit exactly those issues on every scrape. So it's really important now. And that brings me to the last point, which we could consider changing. So OpenMetrics format intended to enforce Prometheus naming convention, notably magic suffixes like metric name, unit, and total. Those suffixes are really critical for PromQL user experience, right? There is currently no other way to tell when you see PromQL kind of expression, if you're on alerts or recording rules, if the metric is a counter or it has base units, seconds, bytes, other than the suffix, right, which we maintain over time. So as a result, OpenMetrics was really focused to ensure those suffixes exist, so PromQL experience is amazing. And this is fine for majority of users, but it poses challenges on the increasing number of users we see, with the main one being from OpenTelemetry, right? So this enforcement intention was meant to really show the issue that if you don't have those suffixes, there are problems, and to convince other systems to change their naming convention, which is opposite. So they really not allow those suffixes, right? But instead, they didn't change their metric convention, but instead they tried to comply in any possible way, which means auto-generating those suffixes, right? And that kind of hurt Prometheus even more, in my opinion. So instead, they developed those translations and they changed metric names. And in my opinion, changing metric names should be forbidden, like on collection side. It only creates new, really impossible to solve problems and confusions. So, should we enforce good names in Prometheus, or should we allow OpenTelemetry names? There's no perfect solution here, but with 2.0, we want to open the space to revisit those enforcement. Okay, that was super long way to explain why we are doing this and what we are trying to do in 2.0 and maybe 1.1 with some smaller changes. But our high-level intentions is this. We want to have 2 clean and efficient flavors of the exposition formats, We want to have a robust OpenMetrics text that is readable and writable and efficient as well. And we want Prometheus protobuf for development, really, to stay ahead, to keep things up to date with the latest Prometheus features. And yeah, so Krajov, can you tell us more about 2.0?
Yes, thank you. So I'll jump right into this for the sake of time. So the first thing I want to talk about is the UTF-8 feature, which Julius already mentioned, already works in Prometheus 3. Actually, you need to use, as you can see, there's a metric there with emojis, you know, and do unit.
Oh.
And the what you need to do to get this to work is to use Prometheus protobuf, or actually unofficially you can already use OpenMetrics and Prometheus text, but these are breaking the standards. So our first proposal is to just bring UTF-8 into the OpenMetrics 2.0. So for example, you could have a label name called Chuang Taima. I'm sorry, I'm probably butchering that, but it's Chinese for status code. And also temperatura maxima, which is Spanish and also Portuguese for maximum temperature as a metric name. And we would allow this in 2.0. And this is already a hint at some changes to the naming conventions enforced by OpenMetrics 2, but we'll get back to that when I talk about suffixes. So the next feature I want to talk about, which already works again, this is Grafana heat map against Prometheus 3.0. This is showing a native histogram. And to get this to work, you can only use protobuf at the moment. But there's a need for the text representation for debugging. Because right now, if you look at /metrics, you don't see this or anything like this. So this would be the proposed format. After the metric name and the labels, before this, you had just a float value. Now you can have a complex type. We denote it with curly braces, and this one is for native histograms. I will not go into the details. These native histograms are quite complicated, so if we try to unfurl this into lines, this would be huge and about the same level of readability. So, and native histograms with exponential buckets are not the first or only complex types that we see coming up. Actually, we see that there's native histogram with exponential buckets already existing. Native histogram with custom buckets already exist, also called NHCB. These are kind of a replacement for classic histograms. There's proposal for native summaries. There's proposal for combining the start or created timestamp into time series directly. And the motivation for this is that we are kind of emulating complex types already with separate time series. But these separate time series have some issues, like they can be delayed compared to each other, or some could be missing, and you get into inconsistency problems, especially when you send them over network. So, and also other systems actually already use complex times like OpenTelemetry, like Datadog and others. But this brings an interesting challenge with regards to the what you see is what you query. So again, this is something that already works. You can turn your classic histograms into NHCB, native histogram custom buckets, but you see that the query is not really querying the same metric that you see in the exposition. And what you see is what you query is no longer true in this case. So with the future in mind, we propose to use complex types in OpenMetrics 2.0, meaning that you will write your classic histogram like this. It will be a complex time with the count, sum, and bucket in one line. And now the query side is much more like what you see is what you query. It's not perfect because the histogram count you need to use a function for, but at least you can forget about the magic suffixes like sum, count, and you can forget about how do I format a float number for the LE label, which has been a problem. And for the future, we speculate, this is absolutely, we are not sure about this, but we can speculate that there will be some syntactic sugar, probably not exactly this one, but some sugar to get to those fields of the complex time type in some way. But what's not a speculation, and we already see this happening, is that because NHCB is so much more efficient for classic histograms, people start to add more and more buckets. So eventually you will see a lot of buckets possibly in this complex type. And we are not quite sure how to make this usable, still readable, and compact. We might just end up adding a few spaces. But for sure, this would enable you to just simply grep for a metric or use less and search, which is great for debugging, in my opinion. Now let's talk about something else. Let's talk about reliability and statelessness and the created timestamp in particular. So as we heard before, in OpenMetrics 1, you need to interpret this text in a way where you recognize that the created timestamp belongs to that counter. And this, in effect, this means that this text means that there's a metric called HTTP request total, and that started at 10 o'clock today, which is that timestamp, and then the current value is 124. Detecting this turned out to be super complicated, as Bartek already mentioned. So our proposal for OpenMetrics 2 is to turn this into a kind of a tag in the line, as we did with exemplars and other timestamps. And it would be probably st at and the timestamp, to be short. St for start time, because that's a bit more widespread as a notion, as a standard. Yeah. Another aspect of reliability is the suffixes. This is, I guess, an infamous example from 5 years ago. This is an open issue from 5 years ago, where the Go runtime metrics exposed in 1.0 run into this problem that you have a gauge called Go memstats alloc bytes, and you have a counter Go memstat alloc bytes total. But due to the naming conventions, you get the same metric family name, which is in the type line, and it's the same for both. And this is explicitly forbidden by OpenMetrics because it says that all the family names must be unique. And so this is not it. And our proposed solution is to just use the same name in the metadata. Metric name is metric name. Obviously, this makes the job of the scraper much easier because it's much easier to match the same string as some subsets. And note that because we are getting rid of the magic suffixes, like some, count, and others, this rule could be ubiquitous. So basically, it could apply to everything, which would simplify things. The other motivation to touch the suffixes, the rules around suffixes, is what we already mentioned, open telemetry, where you define a receive samples counter in OTA SDK, you push that metric to the collector, and when you expose it on Prometheus, on OpenMetrics 1.0, you get the total suffix. And this can be quite confusing. Also, UTF-8 already breaks OpenMetrics 1 rules around the naming of metrics because it allows for many more characters. So we kind of think that OpenMetrics standard should more focus on the interchange format than enforcing things, and enforcement should be somewhere else. And to that end, we say that we now change the text in OpenMetrics 1 and no longer say you must have a total suffix for counter, we say you should. And we still promote Prometheus naming conventions, but the format does not enforce them. However, this loses the nice feature of the naming conventions where you could tell from a name of a metric its type and what kind of unit it has, so which is not great. And also, just changing this word from must to should doesn't change the fact that OpenMetrics explicitly says that you cannot have the same name of metrics. So the conflicting names are still prohibited. And let's look at this through the use case of federation. In federation means that you scrape a bunch of targets with Prometheus, and you collect the metrics, and then you expose them as one exposition. And in this example, from left to right, I'm scraping two metrics. They are the same name, but the unit is different. One is Celsius, one is Fahrenheit. They mean different things. And then when I expose them, it turns out that there's a conflict, which OpenMetrics 1 doesn't allow. And we think that we should allow this, especially because there's already implementations in place to actually solve this by the type and unit labels. That's a new feature in Prometheus. But this also motivates us to solve this issue of not knowing the type and unit in the exposition and the conflicts. So this motivates us to try some alternatives. We haven't decided yet, but try some alternatives on how to get the type and unit back in line into the exposition. All the solutions that you see here, either by adding it as special labels or some kind of tags, or in some format right next to the metric name, these solve the information that you get back the type and unit on every line, essentially making it stateless again. And it means that float samples retain their counter and gauge flavor now in federation, which they lost before. Also, I don't know if anyone used native histograms before, but you might have noticed that they don't have any suffixes. So you cannot tell from the name of a native histogram that it's a native histogram. So this would solve that as well. And also the first solution kind of dictates the implementation as well, which might not be a good idea. I could go on with other small changes, but I'll stop here and hand it back to Bartek.
All right, let's sum it up. So this is sort of the initial proposal we have. The discussions about type and unit right now are just discussions, so it's not even there. And yeah, so we feel it's more compacted, more reliable, efficient to parse. We feel it's consistent with the upcoming changes to Prometheus, especially around native histograms and summaries, holding that what you see, what you query factor. It improves scraping of OpenTelemetry, allows scraping of OpenTelemetry metrics legally without issues. And then is it less or more readable? It's very subjective. Some people are actually thinking that combining summaries are actually and histograms is better. Some people would prefer the old structure. It's really subjective, but I think it's still human readable enough, perhaps. So yeah, please share the feedback after the talk. And yeah, there are other changes, but huge takeaways is T0 is still in progress. We need feedback. Prometheus is evolving, so exposition formats has to evolve too. We are aiming to have a robust, reliable, modern text format to be up to date. We already see when we implemented this, it's takes like 10 times faster on histograms, 2 times faster on CTST parsing. So it should be even faster and cheaper. But we still intend to keep protobuf, not for efficiency, but actually for development. Yeah, so please join our weekly calls, and we are, kind of make this great, even greater together. So that's it. Thank you.
Thank you. All right, so since we're a bit behind, let's maybe take 1 or 2 quick questions in case there are any. There's one. Also, Jan, are you already mic'd up? Where's Jan? The next talk? Okay. Here.
I'll have to take it on.
I was wondering if there is some performance improvement using OpenMetrics, but on the Prometheus side, like does it reduce the storage size, or does it make it more performant, the query, or it's totally not linked at query time?
You mean 1.0 or 2.0? The one we are just working on? So the OpenMetrics initial one was the same as text reaching, right? Yeah, it was the same. But now we are improving things for parsing for sure. It was just making things reliable with adding more features. And it actually makes more efficient to store. So essentially to store efficiently those classic histograms and summaries, we have to pay penalty right now for existing text formats. So essentially it's not only more efficient, but also it enables more efficient storage and PromQL. So yeah, it should be much better.
One more? If not, then also good. Then we can catch up on time.
All right, thank you so much.
Thank you.
All right.